So in this tutorial session, we will try and refresh our knowledge on what superposition theorem says, and also solve some examples so that we can understand it very well. So what is superposition theorem? It states that the current through any element in a multiple source linear circuit, that is a circuit with two or more sources, it could be a current source or voltage source or anything, can be found by taking the algebraic sum of the current through that element when each source acts alone. So what this means is that if we have, for example, this circuit having V1 as a voltage source and V2 as another voltage source, which means there are multiple sources as was stated here. It means we can let this V1 act alone whilst we deactivate this V2. And for example, if you want to find the current through this R3 resistor, this V1 will give a certain current through this resistor. Then we will note it down, and we will also deactivate this voltage source, and we will allow V2 to also operate. V2 will also produce a current through this R3 resistor. Then after, we add the current from V1 and V2, and we should get the total current that will flow through this R3 when this V1 and V2 are both acting at the same time. That is what superposition theorem says. So let's look at this diagram. We can see that when V1 is acting alone, you see that V1 will produce a certain current through this R3 resistor. So let's say I1. And when we take a look at this diagram, we can also see that this one, V2, is acting whilst we've deactivated V1. And V2 will also produce a certain current, let's say I2, through this resistor. So then if we add the current produced by V1 and the current produced by V2, we should get the total current that will flow through this circuit when V1 and V2 are both acting like the same time. That is what superposition theorem states. So let's note this. It says that open circuit current sources during the activation. So I said that we will allow one source to act at a time whilst we find the current through a particular resistor. So what if the source is a current source? This is what we do. We deactivate by open circuiting it. And if it's a voltage source, for example, in this diagram, we short circuit it if it is a voltage source, as you can see. So you see that V1, when V1 was acting, I deactivated V2. This is V2. I deactivated it here. So you see that here is short circuit. And when V2 from here was also acting, I deactivated V1 by short circuiting it. So yes, we will try and solve some examples on superposition theorem so that we will understand it very well. So in our first example, using superposition, right? So it says we should determine the current in the 0.1 ohm resistor using superposition. So if you've watched my other videos, you see that this circuit looks very familiar, right? We used Thevenin and Norton to find the current through this one, and I think we had 1.7. It should be the same if we use superposition. That is when we allow this 5 ampere current source act alone, and we deactivate this, and we also allow this to act alone. And after everything, we add both currents passing through the 0.1 ohm algebraically. Then we should get the current when this and this are acting the same time. So let's see what will happen. For example, when the 5 ampere is acting alone. When this is acting alone, so let's see, can we allow this 5 ampere to act alone? We deactivate all other sources. So in this case, we have a current source here, so we will deactivate it. And since this is a current source, we will open circuit it. That was what we learned in the introduction. This 0.4, 0.1 ohm, 0.5, and this is our 5 ampere current source. So when this is acting alone, we see that this 5 ampere will flow through this branch. When it gets to this node, there will be a split between 0.1 ohm and the 0.5 ohm. But this current flowing from or through the 0.1 ohm won't go through this open circuit because here is open. So it will flow through 0.1 and 0.4. So what I'm saying is that the current, let's say I1, and here is I2. So I2 will be the same current to flow through this 0.4 ohm because here is open. So when it gets to this junction, it won't go through the open circuit, but it will flow through the 0.4 ohm. So it means that 0.1 ohm and 0.4 are in series because I1 will flow through 0.1 ohm and the same I1 will also flow through 0.4 ohm, which means the same current, right? And we know that same current means the resistors are in what series. So knowing our current division rule, we will say that I1, that is the current flowing through the 0.1 ohm, we can say that it should be the opposite resistor, that is 0.5 all over 0.5. That's the summation of this and this, and in this case here will be also 0.5 because so 0.5 times the total current. The total current here is 5, and here we should get 5 on 2 amperes. That is when the 5 ampere current source is acting alone. So let's see, since we are done with this 5 ohm, we will deactivate it and allow the 2 ampere current source to also act alone. So when the 2 ampere current source is acting alone, we will open this current source. This is a 0.1 ohm, this is 0.4, and there's a 2 ampere current source here. So this is 0.4 ohm, 0.1 ohm, 0.5 ohm. So the same ideology, we know that this 2 will flow through this branch, and when it reaches this node, there will be a split between this branch and this branch. So let's say here is I3 and here is I4. So we know that since here is open, the I4 current upon reaching this junction won't flow this or into this direction, but rather it will flow through this 0.5 ohm. So we can say that this 0.1 ohm and 0.5 ohm are in series because this I4 will flow through this 0.1 and at the same time flow through this 0.5 ohm, which means same current. And for what we know that when the same current flows through certain resistors, we know that they are in series. So this and this are in series and they are in parallel with this. So from current division rule, we can say that in this case we want the current through the 0.1 ohm. So I4 should be equal to the opposite resistor, that is 0.4 out of 0.4 plus, in this case 0.1 plus 0.5, that is 0.6, all multiplying the total current, that is 2 ampere, and we should have 4 on 5 ampere. So So now that we know the current produced by the 5 ampere current source and the current produced by the 2 ampere current source through the 0.1 ohm, from the definition for superposition theorem, it says we will add the current in algebraic sum. I mean, it should be algebraic, right? So it means that we will take into consideration the direction of each current. So let's look at the original question. Let's say IL was the current that we should find when this and this were acting alone. So from KCL, we should say that IL should be equal to a certain I1. From here, we know that I1 was a current that was flowing through the 0.1 ohm when this 5 ampere current source was acting, and this was the current. This I4 was a current produced by the 2 ampere when it was acting alone here. So adding I1 and I4 should give us a total current that will flow through the 0.1 ohm resistor when this and this were acting like at the same time. So it should be plus I4. But let's see something. So let's look at this. You will see that IL is facing this way. I1 is also facing this way. So it is I1 is in the direction of IL. So we will maintain this one to be positive. That is 5 on 2. But let's take a look at I4. I4 is opposing the direction or the flow of the original current flowing through 0.1 ohm. That is IL. So we will negate the I4 current, that is I4 current flowing through the 0.1 ohm. So when we come to this equation, IL should be equal to the current which was produced by the 5 ampere current source through the 0.1 ohm, that is 5 on 2, plus a certain I4, that is the current produced by the 2 ampere current source, but in the negative, or in the opposite direction. So this will be 2 brackets minus 4 on 5. So in total, IL will be 17 on 10 ampere. That is the same as 1.7 ampere. So if you've taken a look or you've watched my video on Norton theorem and Thevenin's theorem, I solved this example, or I used this circuit in my analysis, and we found the current through the 0.1 ohm, and we had the answer to be 1.7 ampere. Using superposition, you can also see that we have the same results here. So yeah, so you will find a current that will flow through the 10 ohm resistor using superposition. So we know what we have to do in superposition. We allow one source to act alone, and we note the current that will flow through this resistor, and we also allow the other to act alone, and we also find the current through this one, and we add them together, and we should get the current that will flow through the 10 ohm when this and this are acting together. So I will start with the 10 volts acting alone. So when 10 volts is acting alone, this is how the circuit will look like. So you will see that there was 12 volts here, but we deactivated it by placing a short circuit here, right? So let's say this is 10 volts, this is 4. Yeah. So if you want the current through this one, this 10 ohm, we can use current division if we know the total current coming out from this 10 volts, because when it reaches, or gets to this node, there will be a split between this 6 ohm and this 10 ohm, and we can know the current that will be produced here when this 10 volts is acting alone. So before we can find the total current, we should know the total resistance here, and we divide it by the voltage, and we know the IT, that is the total current. So the total resistance, we can see that this and this are in parallel. So 10 is in parallel with 6, and the parallel combination of this is in series with this 4, so it will be plus 4. So RT here should give us 15 on 4 plus 4. The total should be 31 on 4 ohm. And if you want the total current, that is the IT, for example, IT should be the voltage over the total resistance. That is 10 out of 31 on 4. And this should give us 40 out of 31 amperes. So now that we know the total current produced by this 10 volts, we can divide the current. Using current division. Knowing your total current, you can know the current that will flow through this or this, depending on what you want. So let's say I1 is flowing through the 10 ohm resistor. So I1, from current division rule, we will say that it will be 6 out of the summation of 6 and 10, that is 6 plus 10, or multiplying the total current, that is 40 on 31, which is 15 or 31 ampere. So this tells us that when the 10 volts is acting alone, the current that will flow through the 10 ohm resistor is 15 on 31 ampere. So then when the 12 volts is also acting alone, let's see what will happen. Our circuit will change. This will be the 12, 10 ohm, 6 ohm, and this is our 12 volts, this is our 4 ohm. So you see that we deactivated the 10 volts here by short circuiting it. So if this is also acting alone, this will produce a certain current, and when it gets to this junction, there will be a split between the 4 ohm and the 10 ohm. So since this is producing the total current, by knowing the total resistance, we can know the total current and divide it between this 4 and 10 and know the current here. So like we did it here, the total resistance here, you can see that 4 and 10 are in parallel and they are in series with this 6 ohm. So it'll be 10 parallel 4 plus 6, which is RT, 20 on 7 plus 6, which is 62 on 7 ohms. So if we want the total current produced by the 12 volts to be V out of the total result, that is 12 on 62 over 7, which should give us 42 on 31 amperes. So now we know that the current produced by the 12 volts, or the total current produced by this current from the 12 volts, is 42 on 31 ampere. So then we can divide, using current division, the current that will flow through this or this, depending on what you want. So in this case, we want the current flowing through the 10 ohm resistor. So let's say I2 is flowing through this 10 ohm. So we can say that I2 will be equal to the opposite resistor, that is 4 out of 10 plus 4, or multiplying the total current, that is 42 on 31, and this should give us 12 on 31 amperes. So from the original question, we see that IL was the total current flowing through this 10 ohm when the 10 volts and the 12 volts were acting. So we did them individually. So we can say that IL should be equal to I1 plus this I2 here, because the sources acted alone at every point in time. So let's see. IL is going this way. I1 is going this way and I2 is also going this way. So we are not going to negate everything because I1 and I2 are all in the same direction as IL. So we will say that I1, that is 15 on 31 plus 12 on 31 should give us IL, and that's this should give us 27 on 31 ampere. IL in decimal will be 0.87 ampere. So when you take a look at the example in my first videos, you see that when we used Thevenin and Norton, we had this answer, and superposition also gave us the same results. So we'll find the current I, that is this, flowing through the 23 ohm resistor in the figure below, using superposition as well. So we know what will happen in superposition. We will allow one source to act at a time, and then after that we will deactivate the other, and we will allow the current source to also act at another time. Yeah. So let's say when the 20 ampere current source, that is this, is acting alone. Okay, so this is how the circuit will look like. This is a voltage source, so we will deactivate it. And how do we deactivate voltage sources? We short it, right? So this will be it. This will be your current source. And here will be your 23. Here will be your 20 ampere. This will be 47, and here will be 27 ohm. So we are finding the current here. Let's say here is I prime, right, going this way. We know that this 20 ampere current source getting here was split between the resistors here and the 23 ohm resistor that we want to find. So we can compress the resistors here so that we can divide the current between this and this, and we will know the current flowing through this one using current division. So we know that from here, this is how we compress it. 27 is in parallel with this 47 ohm. So this is how it will look like: 27 times 47 all over 27 plus 47, and this should give us 1269 47 ohm. That is compressing this and this, right? So it will look like this. The new circuit will look like this. Here's a 4 ohm, and the combination, or the parallel combination of this and this, is 1269 on 74. Sorry, this is 20 amperes, and this is the 23 ohm, and this are I prime. So we know that when this current gets to this junction and is split, the current that will flow through this 4 ohm is the same current that will flow through this resistor, and it will divide here, right? So we can say that this and this are in series, so we can add them, so that series combination of this should give us this. So these are 23 ohm, these are 20 ampere, and combining this and this should give us 1565 all on 74. So from here, these are I prime going in this direction. We can use current division. That is the current through the 23 ohm. That is I prime should be this over the summation of this and this times the total current, and in this case 20 amperes. So it will be 1565 on 74 all over 1565 on 74 plus 23 times the total current, that is 20 amperes. So I prime will give us 9.57 amperes. So this is for when the current source was acting alone. So we will allow the voltage source, that is the 200 volt, to also act alone, and we will deactivate this current source. And how do we deactivate current source? By open circuiting it. So this is how the circuit will look like. This will be your 27, this will be your 47, and when the 200 volts is acting alone, here is 47, here is 27 ohm, here is a 4 ohm, and we will deactivate this current source by opening it. So it will look like this, and we will have our 23 ohm resistor here. Let's say here is I prime prime, that is the current flowing through this resistor when the 200 volts is acting alone. So then we know that the current supplied by, or the total current supplied by this 200 volts, upon reaching this node, there will be a split between this branch and this branch. And since here is open, the current flowing through this 4 ohm will be the same current that will flow through the 23 ohm. So knowing the total current here, we can divide the current through this, between this 27 ohm and the 4 ohm resistor, and for that matter the 23 ohm resistor. So let's find the total current supplied by this 200 volts, and we can only find that by finding the total resistance, and we will divide it by the voltage and get the current. So our total, we will see that this 4 ohm and this 23 ohm are in series. So 4 plus 23, that is, they are in series, and they will all be in parallel with this 27 ohm resistor, and the combination of this and this will all be in series with this 47 ohm. So RT, this should give us 27 parallel 27 here plus 47. So RT give us 27 on 2 for this plus 47, which is 121.5 ohms. So we can now find the total current that is produced by this 200 volts. So it will be 200 on 121 out of 5, which is the same as 400 121 ampere. So now we know that the total current supplied by this 200 volts is this. So then we can divide the current that will reach this junction between this side and this side. So we can say that the current through the 23 ohm, that's the I prime prime, since this and this are in series, we can combine them to be just one resistor, that is 27. So let me draw so that you see how it will look like. It will look like this. So this will be your 200 volts, and 4 and 23 are in series. So here will be 27 as well, because 4 plus 20, they should give us 27. And here is the 47 ohm, and here is also the 27. So finding the current, that is I prime prime here, I prime prime will be equal to the opposite resistor, that is 27 plus 27 times the total current that we found, that is 400 on 121 ampere. So I prime prime will give us 16582 amperes. So then in the original question it says we should find I, that is I going this direction. So I should be equal to when the current source was acting alone and the current was I prime going the same direction as this I, and when the voltage source was also acting alone, we had I prime prime here also in this direction, and we had I prime prime to be this value. So adding them, you should get the total current that will flow through this 23 ohm resistor when this and this are both acting the same time. So for I prime we had 9.57, and then for I prime prime we had 1.6582. so I, that is this, should give us 11.228 ampere. So we are to determine the current through the branches XYZ of the two source network using superposition. So we can apply superposition here because we have multiple sources, that is this source and this source, and the branches X, Y, and Z are this, and this. So in superposition we will allow one source to act at a time. So starting with when the 4 volt source is acting, so when 4V is acting alone, so this is how the circuit will look like. We will deactivate the other. So since this is a current source, we know what to do. We will open circuits, right, like this. So here will be 4 ohm, 2 ohm, 2 ohm. There's a 4 volt. So for instance, let's say this 4 volts is producing a current, say I1. When it gets here, this I1 won't split because here is open. So this I1 will be the same current to flow through this 2 ohm over here. So this is very simple. Taking this loop using KVL, we can find the value of I1, that is the current through this X branch and this Z branch. So in this case there will be no current in the Y branch. So let's see what will happen. From KVL we know that 4 will be equal to this, and this are in series because this I will flow through this and this. Same current means series. So 2 plus 2 I1. So I1 in this case will be 4 out of 4, which is 1 ampere. So in this case we have the X branch to contain 1 ampere, and the Z from here you can see this one is the Z to be also 1 ampere. So that is when the 4 volt source is acting alone. So let's see what will happen when the 2 ampere is acting alone. So we will redraw the circuit, and in this case we will deactivate this voltage source because we've already used that one over here. So how do we deactivate voltage source? We short it, so it will look like this, and this will be our current source over here, that is 2 ampere. Here is 4 ohm, 2 ohm, 2 ohm here. So we know that from the onset, you should know that this is a Y branch, right? And this will be the current that will flow through this 4 ohm branch, or in this case the Y branch. So without even solving or doing anything, you will know that the Y branch in this case, or current in the 4 ohm, should be what? 2 ampere. Right, this 2 ohm, this 2 ampere will flow through this 4 ohm, and when it gets here, this junction, there will be a split between this. So let's say here is I2, here is I3. We can use current division to know the current through this 2 ohm resistor and this one. So what will happen? So if I say I2, I mean the current through this X branch. It will be 2 on 2 plus 2 times the total current, that is 2, that is 1 ampere. So in this case the X branch, so I2 is equal to the X branch, that is 1 ampere, and I3 will be the current in the Z branch, So it will also be 2 on 2 plus 2 times the total current, which is also 1. So I3 is equal to the Z branch. But let's see. When the 4 volt was acting through the X branch, we had I1 going this direction, and when the 2 ampere current source was also acting in the X branch, the I2 was going this way. So it is algebraic, right? So they are in opposite direction. So it will be I1 plus this I2, but in this case I2 should be negative. So in the X branch we'll have I1 we had 1, and we had I2 to be also 1, but in this case it is in the opposite direction, to be -1. So we will have 0 ampere in the X branch, and current in the Z branch. Let's analyze it. The Z branch, this is it. This is a Z branch, that is I1. So let's say Z branch should be I1, and let's see when the current source was also acting. I3 is also in the same direction as I1, so plus I3. So we had I1 to be 1 plus I3, which is 1, but in the same direction as I1, so it will be 1. So Z will have 2 amperes flowing through that branch. But we know why already. Why from here we had 2 amperes. Thank you.